we are going to just finish this last page in your notes. Okay, here's your pop quiz. It's not really a quiz. What do we call the point where the three perpendicular bisectors of each side in our triangle intersect?
Point of concurrency.
Which that means that they have a common point. It's called a circumcenter. Nice. Yes. Okay. What do we call the point where the three angle bisectors intersect? In-center. Correct. All right. So we did one example problem with the in-center. We're going to try one more here. It says N is the in-center of triangle ABC. So just based off that fact, we know that's where all the angle bisectors from each angle intersect. They don't have them drawn on here. Let's go ahead and draw them. If you want to use your protractor to make it nice and straight, you can. We'll use them in a second. But each of these angles are going to be bisected. And they're going to intersect at the in-center, which in this case is point N. All right. Now, the theorem we talked about is that in-center is equidistant from each side of the triangle as long as we talk about like the shortest distance, aka the distance like perpendicular to each side. It's not a perpendicular bisector, but it's the distance from the in-center to each side, and they're all equidistant. Okay, that's the characteristic of an in-center. Here it says we want to find NF. We want to find this distance. If ND is 2x minus 5, and NE is negative 2x plus 7. Well, since we know those are all equidistant, how would I set up an equation to solve for x? Gwen?
2x minus 5 equals 0 to 2x plus 7.
Perfect. Set them equal to each other. We know they're the same distance. So, solve for x. Do that really quickly. X is 3. Now I want to find NF, and you're like, I don't have an equation for NF. But I know it's equidistance from all the other ones, so maybe I'll use the equation for ND, which is 2x minus 5, and I know x is 3. So I know ND, 6 minus 5 is 1. And I know NF is the same as ND. It's also the same as NE, so you could use any of those. So what will the distance of NF be? Also 1. Yep. Okay, that's kind of fun. Last one here says if the measure of angle ABC is 58 degrees, find the measure of angle ABN. All right. So ABC, we're talking about this one. We know that entire angle is 58 degrees. So what would the measure of A, B, and B? Well, since N is the in-center, it means it lies on the perpendicular bisector. So to find that angle, I would just have to do half of 58, which is 29. So that'd be the measure of angle ABN. Because we know it's the in-center, it's on the angle bisector. Okay. That's all we have to do for that. We're going to do a couple constructions, but they're not like full-blown constructions. Obviously, I didn't give out a compass. I just gave you a protractor. So we're just going to kind of estimate these a little bit. They're pretty fun. So everybody look at the bottom here. The first one we're going to construct is a circumcenter, which we said that's where the perpendicular bisectors intersect. And then second, we'll do the in-center. Okay, let me get my dot came up here. Ooh. Libby, do you want to flip on, I think it's the one on the right. Switch. Right, that's left. Right. Right. Yes, that one. Thank you. I think it's a little bit easier to see with that light on. Okay, let's do the circumcenter first. So we're basically just going to use the protractor because it also has like a little ruler to estimate the midpoint, even though there is ways to actually construct the midpoint like with a compass. We've done it before. I think we did. So basically we're going to use a rule and find like halfway from each side. All right, so I'm just going to start with this bottom. And I'm going to use the ruler side of this. And you can see here's 1.5. So it's like 1.5 plus a couple more hashes. So I would probably do about like 3/4 plus like one more. That's about half. All right, did you follow my math there? So half of 1.5 is 3/4. And it was just a couple more tick marks. So it's just one tick mark. And as long as your point looks kind of in the middle, we're not doing it exact. All right, so we're just using our ruler to find about halfway. All right, now we're going to do the same for the other two segments. I'm going to come over here. This one looks like it's a little bit more than 1.25. Oh, wait. Yeah, a little bit more than 1.25. So again, you can count the hash marks too if you want, like 1, 2, 3, 4, 5, 6, 7, 8. We know there's 16, 17, 18, 19, 20, 21, 22. So about 11 hash marks. 1, 2, 3, 4, 5, 6, 7, 8. About 11. Or you can, like I said, do the math. We're just finding about halfway. All right, last side here. This one looks pretty similar to that other side where it was, well, this one's about exactly 1 3/4. Would you say? Yeah, 1 3/4. So maybe about here. Okay, there's step 1. Use the ruler part to find the midpoint. Now using more so like our straight edge, we're going to draw a line that's perpendicular to each side of the midpoint. So you're essentially going to take this horizontal line right here and we'll kind of like rotate our triangle around. And we're going to draw the perpendicular side, which would be like a vertical line. So again, we're not doing this exactly with like slopes or anything by any means. Just draw as perfectly as you can a line that looks like it's perpendicular, aka forms a right angle with each side. So I think it's easiest to kind of twist your paper and make each side like horizontal. Like that. And then just draw like a bunch of vertical lines. Again, there is exact ways to do this with compasses, and maybe we'll get to that eventually, but for now we're just kind of making our connections here. All right, so now I'm really twisting this to get this side horizontal. I'm doing the best I can on this dot cam. I know it's not easy. Now, if you do this pretty precisely, they should all cross at a common point. If yours don't, they should be pretty close. Okay, everybody make a point there. Did yours cross at a point? Are your midpoints at least kind of legit? Are your lines perpendicular?
No.
Hey, that one's not.
Yeah.
There's your problem. Okay, fix it so that they do cross at a point. If you're like pretty off, you obviously probably did something wrong. But if you're just like a little off, it's just because we're estimating and we're not finding exactly. We're not constructing exactly. Okay, what point would this be? Yep, circumcenter. Okay. If you didn't quite get it, ask somebody next to you for a little bit of help. The next, we're going to do an in-center, which is where all the angle bisectors intersect. So we're going to just like kind of estimate each angle. This is why you need the protractor. All right, so I'll start with measuring like this angle down here. I know this triangle isn't labeled. You can label it ABC if you want to, but I'm going to extend this line a little bit. It's easier for me to use my protractor by putting this little cross piece at the vertex. And it looks like it's about maybe like 48 degrees. What do you guys think? About 48, 49? I'm reading these numbers over here. I'm doing the bottom right-hand corner one. Do you agree?
Yeah.
Okay. So I got to do a little bit of math here. We're gonna bisect this in half. So what's half of 48? 24. Here's 25. So 24, put a little tick mark there, would be about there. Okay, see how I did that? I just found half of it, half of that, 24. And then to draw that angle bisector, use a straight edge from the angle to that marking of 24 degrees. And that will split that angle into two 24-degree angles. Okay, the next angle I'm going to do is this bottom left one. So this time I'm going to kind of extend this side of the angle, this ray. Put it on this vertex, line it up with the bottom there. Looks to me like it's like 69-ish, maybe not quite 70. Half of 70. And remember, I use these inside numbers because this is an acute angle. Is 35. Now, I did say it was like 69, so maybe just a little less than 35. 35 would be right in between 30 and 40. Can you see my dot camera? Not really. Oh. There, I see it looks a little darker. Okay, so let's draw that angle bisector. Isn't this fun? Bisect that angle. I feel like it's the lighting off the focus. There, that looks a little bit better. Okay, everybody good so far? All right, top angle is the last one. So I'm gonna have to twist my paper a little bit here. Maybe I'll extend this side. Line it up here. Looks like it's about 65? 65 or like 64. Half of that's about 32. Obviously I'm running out of room right here, so. Can you see this? Okay, there you go. It's about 32. I'm gonna mark it on this side because I can't really mark it on that paper. Now again, if we do this pretty precisely, mine looks like it might be a little off here, but they should cross at a common point. If you need to just draw your dot bigger, you can do that. Like so. This would be the in-center. Did you get that one? I think that one's a little bit easier to do than the perpendicular bisector. Okay, so just some pretty like basic constructions. We didn't get too in depth with it. There are ways to do it with the compass. It's really fun. Maybe we'll do it sometime. All right, that's a wrap.